25th.
Oh, now start.
Okay. Today is May 25th, 2022, and we are in the second session of our track 4 on hazards and space ontology or space ontology. Ontologies are the general theme, and space disasters is the track theme. And we are very happy that one of our colleagues who has been very active on our forum and is also co-champion of this track, Robert Rovetto, is going to speak to us on space hazards and space ontology. But I am going to request our chair, our forum chair, Professor Ken Baklowski, to give a introduction both on his talk as well as on his background. I have been very satisfied and happy colleague of his, off and on, talking both on the forum for a few years as well as off the forum. And I wish continuing progress to Robert, and I hand over now the mic to Ken Baklowski. Thank you, Ken.
Thanks, Ravi. So Robert Rovetto has been a member of the Ontolog community for a long time, 10 years, and has been very active in Ontology Summit activities, Ontolog Forum activities, and the IAOA as well. He's been involved in international committees in areas such as aerospace, maritime, specifically in the Center for Orbital Debris Education and Research. Robert has a background in ontology, conceptual modeling, terminology, AI, data ethics, and ontology development methodology, as well as specific areas of aerospace and maritime emergency response. So he's a perfect person to be speaking at our session today. And he's actually a member of the organizing committee of the Ontology Summit 2022. So we've been working together on developing this whole summit. And he's specifically co-chair of this track because of his extensive background in this area, co-chairing it with Ravi. So I'm really excited today to be hearing from him about space hazards and space ontology. So he'll be giving us an idea of how all of this that we've seen in talks by, well, actually 2 talks, Ravi, you're too modest. You've already given the first talk in this session, in this track. And the second talk last week by Scott Hull. But what we really need is more about how you ontologize all of this, where ontologies serve. And so it's my pleasure to introduce Robert Rovetto now, who will be enlightening us on this whole subject area. Robert?
Thanks, Ken, very much. Also, thank you, Ravi. I'll just start screen sharing now. Can everybody see full screen?
Looks great.
Okay, great. Thanks. So like Ken and Ravi said, I'll be speaking on space hazards and space ontology. And I hope I can get through the slides. There were a lot in the beginning, but I've been able to cut it down a bit. So this is a brief bio, but suffice it to say, as Ken mentioned, I'm involved in a few different committees, and you can visit some of the links at the bottom. And if you have any questions, just contact me separately. So there's a number of space hazards that we can discuss, and a number of them are human related, others are natural. And that's basically the distinction that I'm going with for this presentation, artificial versus natural. So for example, on the upper left, we have spaceflight traffic, which is a burgeoning topic in the astronautical community nowadays. We also have orbital debris, which we heard from a NASA colleague about their orbital debris program office and their activities in our last session. There's also the hazard of near-Earth objects, namely asteroids and comets. We also have malfunctioning spacecraft is a hazard associated with space flight and space in general. We have intentional attacks, which is a growing concern nowadays as the space industry grows and as the risk of cyber attack becomes more common. We also have astrometeorology, colloquially known as space weather, and that involves solar activity as well as you can consider extrasolar and galactic phenomena, which I included in particular because that's an undertreated area. I think of both astronomy as well as hazards associated with space. So this diagram is, I think, captures a lot of that. It's from European Space Agency. So beginning with the natural phenomena, namely astronomical phenomena and the risks associated with it, on the left side we have some of the mentioned phenomena. So we have at our local level, namely our solar system, we have near-Earth objects and things like micrometeoroids, which Scott Hulp also discussed in his NASA-related presentation on orbital debris. Asteroids, comets, again, solar activity, which involves magnetic storms and other phenomena. And then the risks associated with that, which can become disasters, are collisions with Earth naturally, damage to life on the ground in orbit, damage to infrastructure ranging from artificial satellites to ground support systems to social infrastructures, and then specific damaging effects on services as well as resources. So everything from basically internet to power grids to various other services. In terms of the artificial activities of concern, or in general human activity that can potentially be hazardous, are some of these on the left in the gray box here. So they may be intentional or they may be unintentional. So for example, accidental orbital debris creation, and that may be through activities such as the accidental release of mission-related objects during spaceflight activities. Also geopolitical aspects. So there's in the global theater within the space traffic management community, there's a lot of players, being a multilateral theater. And so I added that as a particular concern as a reflection of some of my committee involvement, seeing some of the discussions that take place. Also what they call mega constellations. So these are artificial satellites sent up as groups in order to provide some sort of service. And that in itself is not necessarily problematic, but the proliferation of various numbers of satellites introduces increased risk of collision if not coordinated in order to avoid collisions. Spacecraft close proximity maneuvers, so basically the traffic or the maneuvering of spacecraft near each other is always a high risk activity. So deliberate hazards, namely, or deliberate activities in which can have some damaging effects, are things like anti-satellite activity. And there has been a number of examples from distinct countries on launching missiles to destroy orbiting satellites. Intentional attacks, things like cyber attacks on spacecraft. Also, if you look in the news, there are stories in which that has occurred on occasion. Activities such as jamming, there's a typo here, but jamming, which is radio frequency interference. There are activities or attacks called kinetic attacks, physical attacks, in which it's a direct launch of some physical object on the satellite. And then, as I mentioned, geopolitics. So there may be deliberate actions by global stakeholders or nations to cause some sort of harm, for lack of a better word. So again, the risks, the hazards, or disasters range from damage to people, property, services to posterity, of course, the future of spaceflight activity. And specific examples include on-orbit collisions, interference with ground-based astronomical observations, interference with communications, and the disruption or destruction, of spacecraft, their parts and their functionalities. And that results at times to loss of services. And as I mentioned, geopolitical conflict. So the data that may be of importance to the ontology community include both the natural and the artificial phenomena, namely natural astronomical phenomena. So astronomers collect various observational data, artificial orbital debris, micrometeoroids. Also observational data is critical. Something called space situational awareness encompasses orbital debris activities or orbital debris observations. Human activity through persons or use of robotics. And so the data varies from observational to operational, namely spacecraft operations, to the collection of various raw data in catalogs, the processing of that data to yield information that can be actionable for things such as spacecraft avoidance, spacecraft collision avoidance maneuvers, whether it be a spacecraft and an orbital debris object, or whether it be two active spacecraft needing to avoid one another. So there's a lot of modeling, there's a lot of predictive data, and a lot of coordination that goes on with some of these artificial activities. And of course, there's more specific data, such as experiments and materials found in platforms such as the International Space Station or other platforms. And so that data is of interest to domain scientists, whether it be chemistry or interdisciplinary fields. As mentioned in our previous session, orbital debris is one particular concern. I included this slide since it was historically a motivating area of interest for myself, but I will leave this to the audience to see our previous speakers talk. Suffice it to say that there's a good amount of data on this topic. A couple of activities in the global community for solutions toward space-related hazards or disasters are these two. On the left, we have NASA's Planetary Defense Coordination Office, in which we see a number of missions ranging from the search, the detection and tracking of objects in our near-Earth area. We see the characterization of the data that is gathered and the objects that are observed. They have mitigation activities and research into how to prevent calamities and disasters on Earth from objects such as asteroids. On the right, we have an interesting activity, which is the International Charter, Space and Major Disasters. And it is approximately 207 artificial satellites from various nations, and they've effectively signed an agreement in which each of the signatories can request data on from those satellites. And if you go to their website, you'll see basically a map that describes some of this activity. In summary, for this particular part of the presentation on space hazards, I've tried to list some general groupings. So on the left we have hazards, on the right we have disasters and damage, and I've explicitly distinguished between hazards and disasters because there are some conceptual and semantic reasons to do so. In past ontology summit sessions or past sessions in general, some members of our cohort also mentioned that distinction, so I made it here. And on the bottom in the red, this particular quote I think is relevant from the European Space Agency, where we read, "Many hazards have been identified originating in space, which, although unlikely, continue to pose real dangers to our way of life, and in the worst cases to human health and safety." And so I thought that captured a number of the hazards associated with space. Now, some examples of ontology-related efforts, broadly construed to include knowledge organization systems, everything from control vocabularies to semantic nets to ontologies. So on the left, we have European Space Agency. So over various years, they've had project-specific and organizational endeavors to do things with knowledge organization systems, such as in 2008, they had projects for asteroids in which they created a database for trajectory optimization and automated classification. Now, more recently, they are actively engaged in model-based systems engineering, what NASA typically calls model-based engineering, so MBE as opposed to MBSE. And they're concerned with things ranging from requirements management to various other aspects of space flight and space in general. And the general theme for this activity in ESA is moving from documents to digits, or digitizing their systems along those lines, which is trending nowadays. On the right, we have NASA. Again, over various years, NASA has been active in the use of knowledge organization systems, and they've had various project-specific explorations and projects. So in knowledge management, they currently are active in that space. Also, artificial intelligence applications in autonomous vehicles. They've explored taxonomies. For example, if you search the NASA taxonomy online, you'll find that. Also some semantic technology applications and thesauri. You'll also see the NASA thesaurus. These are some of the references for this part one. Now, the part two is about ontology specifically. And so this part, I'll be talking about my personal project for developing these knowledge organization systems for space. So this is a fairly ambitious vision that is about creating a set of linkable and modular ontologies. So some small, some larger, and other knowledge organization systems to effectively create a set of these models. And to date, it has been a manual ontology development process, and the audience should be aware of the various types of development methodologies, automated versus manual versus a hybrid. I've been limited to the manual ontology development, which is more time consuming. And each of the project tasks, or I should say some of the project tasks, are distinct, but they are related. They have related goals. So some can be standalone tasks for particular types of knowledge organization systems, and I'll get into that later. And related keywords for this, given the broad scope of knowledge organization systems, again, are model-based systems engineering, knowledge graphs, semantic modeling, and so forth. And in the center bottom, those two links go to the project landing page that describes the project. Some examples of living ontologies. On the left, we have the orbital debris ontology. This is an in-progress ontology in which I try to categorize debris as well as the characteristics of orbital debris objects and phenomena, aiming for also eventually capturing the dynamic evolution of the orbital debris environment, the causal provenance or the causal history, environmental aspects, and so forth. Now, I described this in part in a 2015 paper in Earth Science Informatics. And on the right-hand side here, we have the Space Situational Awareness Ontology, which is an ontology effectively broader than the orbital debris ontology to capture the activities and infrastructure that yields situational awareness of the orbital environment. And that includes ontologizing basically observational and SSA data, as well as tracking data. And that was in a publication with Dr. T.S. Kelso and myself in 2016. And the overarching aspect of these and other ontologies in this project are basically to explore flavors of the model. So different knowledge organization systems, different degrees of complexity and implementation languages, as well as different use cases. So another example of a living ontology is for astrometeorology, also called cosmic meteorology or space weather. And so this is an example of a potential conceptual model in which causal relations are involved between the actual phenomenon and the effects. And so we see some of these categories on the right-hand side. Another example of some living ontologies is the orbit ontology or the orbital category ontology model. On the left side, we have some of the categories displayed in the Protégé ontology editor. And so there are potential taxonomic structures to them, and each of the categories can be, as the audience knows, formally defined according to various parameters. So in this case, the orbital parameters as found in the orbital dynamics literature. And there are various parameters that you can use for categorizing types of orbits. On the right-hand side, we have an example of an ontology design pattern for the same topic. And this is displayed and implemented in a separate implementation language and tool. This is the ORM, it's called. And what is nice about this tool and this implementation formalism is that it visualizes the content that you're trying to capture in natural language, and it uses full first-order logic, if not mistaken. And so again, an overarching aspect of this project is to capture generic knowledge of the target domain, ideally in a first order, if not higher order logic formalism, but as well as specific knowledge as well. And so that leads into the concept of what today folks are calling knowledge graphs. So here we have a number of diagrams I developed in this process for various aspects of this topic. So this ranges from types of orbits to components of spacecraft. Some of these, namely the one on the right, were also developed by colleagues out of NASA, who I'm happy to say are here today. Some of these are in UML on the bottom right in the orange, and that is more along the lines of model-based systems engineering. So some living and anticipated output of the tasks involved in this project involve the following. So one fundamental task is content collection, and the output includes living catalogs of various terms and definitions of or relevant for the domain subject matter, as well as living catalogs of data sources relevant for the ontological representation or the semantic annotation of that content and that data. Other anticipated or living output of the tasks include the actual modeling activities, so the conceptual, semantic, or ontological modeling. For a given scoped topic, I'm basically forming term lists, trying to identify ways to classify the phenomena in question, as well as the data, and create graph diagrams expressing the conceptualization. Some of the other output includes living catalog of the knowledge representation translations in distinct formal languages. So given a generic statement of the domain knowledge in natural language, what is a knowledge representation and reasoning in the sense of AI translation for that? Also a living catalog of mappings or crosswalks to other knowledge organization systems, or I should say other glossaries and so forth. Also development plans and activities. So I have a number of plans for external knowledge organization systems of this topic area that I would like to pursue given the opportunity. And of course, more papers or concepts than I can count. And the implementation. So the working ontologies are intended to be in distinct computable formalisms and tools, like I mentioned, and to explore competency questions. So for example, what type of orbit is a given satellite in? How many satellites are at a given altitude? Is there a risk of collision between two distinct satellites, and so forth? And then finally, miscellaneous project plans, such as the terminology synchronization or harmonization or mappings between distinct sources, whether ranging from agency sources of glossary terms to project-specific sources. So I have separate projects in which I'm trying to contribute to the community in that regard. Now here we have two visualizations, and these are an example application of one ontology. A colleague out of NASA who, as I mentioned, I'm happy to say is here today. He created a very nice visualization, and together we have a NASA technical document. So I will start playing these short videos. So here, using our JSON LD and some other content, basically we output a table of the orbital parameters of the planets in our solar system, and some of this activity used the categories from some of my ontologies. And so this is an example, very interesting application for ontologies for this topic area. Although this is not specifically for disasters or hazards, it shows applicability to the space community in general. Now, some project components and tasks specifically, so that I have the terminology side of the project, which is the collection and the comparison of various vocabularies and domain-specific phrases, as well as the data and their schemas or metadata. I also am making recommendations based on that comparison and that analysis, potential crosswalks and harmonization efforts, as I mentioned, for external projects. And this is a standalone activity which has value in itself, but it is also a project task of the ontology modeling. The knowledge modeling itself involves the scoping of the topic areas, conceptual modeling, and that includes both qualitative and quantitative. So to start, it's a high-level qualitative capture of the core or the key terms and the key concepts and the key phenomena at a high level for the target disciplines. But given the quantitative nature of these disciplines, it must include a large number of quantitative data and quantitative aspects. And as I mentioned, knowledge representation, so largely symbolic approach, so logic-based, but I would like to explore other approaches. And then the implementation goals for the project involve various tools. So what are some tools and techniques for taking that conceptual modeling, that ontological modeling, and making it highly computable? And so I'm looking at distinct computable languages from common logic, to the ones I mentioned, ORM, as well as knowledge interchange format. And what are some development environments, visualizations, how to modularize, how to collect instance data, and so forth. Now, these two components involve the knowledge graph development and are also along an interdisciplinary approach with applicability across domains. And this also, overlapping aspects involve conceptual analysis and formal ontology, as well as perhaps the more esoteric philosophical questions. Coming from a philosophical background, I'm interested in those questions, but I have a focus on more practical concerns as well. And so these overlapping all of this is the documentation, the revision and the refinement of the models, as well as the call for collaborations and the identification of use cases. So a more specific example in the documentation. So in progress ontology requirement specification documents for each of the models, as well as in model documentation. So metadata of the ontology constructs, whether they be classes or otherwise, as well as I mentioned, the catalog of the terms and definitions relevant for the given topic areas. And as a personal project, it's more than open to formal collaborations, and these are some potential areas of collaboration I'm interested in. If anyone is interested, please kindly contact me personally, and I'd appreciate any of your input or suggestions and collaborations. Thanks so much for your attention, especially to Ravi, to Ken, to Scott and Yvonne out of NASA for their helpful input on the presentation, as well as to all fellow summit organizers. And yeah, I thank you with that.
Thank you very much. That was very enlightening about all of the ontological aspects. We do have some questions. I believe Gary and Ravi. Let's see. Well, let's begin with Gary.
Gary, yes, please.
Well, yes. So the first question really was about whether there are authoritative vocabularies for this area you're talking about. There may be multiple ones, but often efforts like this start with one or two vocabularies that may intersect and together may be comprehensive, or people may take multiple vocabularies and try to harmonize them. So I was wondering what you could say about your sources for terminologies.
Sure. So there are a number of glossaries and a number of sources for various sets of terms and definitions, and they range from agency-specific sources, and they may be online platforms, they may be in the glossaries of their own technical documents or standards. And so I'm specifically drawing on activities and organizations that I'm either part of or have researched. So they range from space agencies to project-specific output. In terms of your question about authority, I can't speak to whether there is a single authority or a larger authority. I tend to not focus on authority, since even perceived authorities can be incorrect in their statements or their content. So I try not to focus on what is an authority, but rather look at the content and so forth. But suffice it to say, drawing on agencies, drawing on nonprofit organizations, as well as project specifics, as well as textbooks, as well as research papers and so forth. So it's pretty scattered in general. So I wouldn't say there's necessarily an authority, but as I mentioned, so space agencies have specific offices. So NASA has their own offices. ESA has their own offices for some of these phenomena.
Well, let me just respond two ways. One is I was talking about authoritative as opposed to an authority. So authoritative is a judgment. It isn't necessarily from an agency that says, we're the authority on this. It's more of a field judgment where essentially you've got relevant domain people, enough of them, who are essentially saying this to me makes sense and authoritative. So I look for vocabularies or glossaries that have that type of seal from the domain people and not from an agency and so forth. But the other thing is a request, because we're going to be publishing a communique at the end and a synthesis. And so I think it would be really nice to have a list of some of these as a base to show examples of in this particular area where people draw from. Okay.
Thank you for your comments.
So Gary, you have this question about upper level reference ontology?
Well, yes, we're getting towards the end of our disaster discussion, and we've covered a number of types from the biomedical and the environmental and so forth. So I was just wondering whether, as Robert and his colleagues have looked into this, whether they connect to any other higher level ontologies that maybe are in parallel but have a higher level, so that essentially the idea of what a disaster and what a hazard is and what a mitigation is and things of that nature are in common. So this is sometimes called an upper level reference ontology. We have one for hydro as an example, because there's different type of water uses. So people said, hey, let's put something together that makes sense. And Robert did mention a design pattern, I believe, in passing. Sometimes a design pattern, such as spatial temporal type of things, is also useful for this purpose, where an upper level design pattern says, these are the basic elements, these are the basic relationships. You're going to sub-specify these as you drill down to different types of hazards and disasters. So I was just wondering if you have any connections to the other types of disaster hazard ontologies in that way.
I can only speak to some views on the use of those sorts of reference ontologies. So in terms of disaster specifically, there are, as you know, and as was shown in previous sessions, there are disaster and hazard related ontologies that try to model some generic aspects of these concepts. But in general, there are many ways to model a given topic area. So one concern I have with the use of the more generic models, although I'm personally intellectually interested in them, having been that being a focus area of mine during my studies, in terms of both practicality and ethics, I'm concerned about some of the use of the most generic aspects of ontology, since it would sort of prescribe a single model upon all concepts or upon all data. But in general, there are ways to create many different models for a given topic.
It's a good point. There are two things which are relevant. If I'm interjecting in between, and I know Mark is ahead of me, Mark Underwood, we'll come to that in a second. But there's a thread from Gary's question and your excellent presentation, Robert. I agree with two important things we need for understanding this summit, especially the space ontology track, and that is we should at least give example if we have references, as well as what you have created, Robert, as examples of upper or top level, I don't know what word to use, but conceptual space ontology organized for at least different purposes. For example, from debris point of view, from classification of satellite type point of view, from orbit type of point of view, from lifetime of decay point of view. So some kind of an entity relationship diagram, if we can create, and some kind of high level ontology if we can create that, would form a good introductory part of our track 4. And we can deliberate some of it offline as well, but this is a point to be made. And just in interest of time, I'm going to first request Mark Underwood to speak, and then if Ken would permit, I would like to speak.
Well, thanks. This will be short. I just wondered if you could say a little more about how you used ORM. There's some wide adoption in some software engineering communities with that, but I hadn't heard of it getting used for ontology development.
Sure. ORM is a fact-based reasoning formalism, and it's particularly common or particularly used in, as you mentioned, some communities, one of which is in Europe. I used it for some of the modeling, and I still do where time permits. What I like about it is that when you use the plugin in a given environment, as I mentioned, it actually verbalizes what you're trying to capture. So there's an interface. The graphical user interface is basically a combination of the symbolic constructs, the visual elements, as well as real-time visualization of what those constructs and their connections mean in natural language. And so that I thought was pretty nifty. And given that it has high expressive power, that is also what drew me to it. I hope that helps.
Yeah, I think I might be confusing this with object relational methodology, which is something else, but good to know. I'll look this up. Thank you.
So what is it called? May I again, what does ORM mean, Robert?
Yes, it's a object role model or object role modeling.
Object role rather than object, what was?
Object relational modeling.
Yeah, ORM versus object role model. Yes, that's very close, but different semantics, role and relations.
Well,
Role is
relational model is a data model.
right, right.
Oh, we have but Ravi, do you want to go first, or
Who else is
Janet
there?
has her hand up?
Who?
Janet.
Oh, Janet, please go ahead and I will defer for a few minutes.
Thanks, Robbie. So Rob, I appreciate the breadth of your vision, and I frustrate collaborators because I similarly want to move the whole Titanic along with all of the different facets, and don't want to put anything into writing until it's really mature and everything is brought along. But have you thought about prototyping some narrow aspect of your vision? And, as Gary was suggesting, taking a few communities as a starting point, taking their vocabularies as a starting point, and then with the aim of eventually getting to the rest of it. But can you see that working, and have you thought about or tried to take that on?
Thanks, Janet. Yeah, absolutely. So yes, and I some of my project plans are specifically to do that for specific topic areas or specific groups. But suffice it to say, the degree of work involved and the degree of time consumption is such that, given let's say personal situations, formal collaborations are necessary to put in that amount of work and time. Yes.
Well, what about cutting it down, cutting down the prototyping to, you could do a back of the envelope prototyping. You can cut down the prototyping if you're thinking more of an agile kind of approach to your whole project. You could start somewhere. That's the question, is starting somewhere with with an idea of a path that once you prototype something, you could iterate and fit it in with your available resources. And that would give you something in hand to, that would be more of a, something that you could share, that other people could get more sense of what you are talking about, where you're going, what's the value proposition for ontological modeling in this arena. You need an elevator speech. You need to be able to go not just not your broad vision, which actually might frighten people off, but something that you can sketch out even without the details. Sketch sketch how it would work.
Yeah, absolutely. I agree with you. If you're open to talk offline, I'd certainly be interested to hear your thoughts more. And as I mentioned, I'm certainly open to various collaborations as well as mentorship and any ideas. So I think I'm one of the younger folks in the group, so I'm keen to hear your and anyone's suggestions. But yeah, you're right, Janet. Thank you.
I wonder if this could be fit in with the idea of what Gary said about the communique. Could you do more of a prototyping sketch for the communique, and then it would get that out into the world? So thinking of that as an opportunity for communicating some slice of how you're looking at this. Maybe in terms of the value proposition of ontological modeling for space disaster situation.
Wonderful, Janet. Thank you so
Thanks.
much. Yeah, continue, please.
Okay, now that's what I have. Now you take over, Ravi.
No, I mean, what a wonderful idea. It's a lot of work Robert has put in this field, especially the first part as well as the second part, where he has personally done a lot of research work. And it would be nice through our medium, through Ontolog Forum, through the communique, to be able to share such creative outputs, even though these are preliminary, conceptual, at top level, or whatever you want to call it. And then the second point which Gary made, which means how can we at least provide links to and discuss a little bit on the content of some authoritative sources of data, such as NASA space ontology efforts, such as ESA, and I'm sure others are as well, so that we can understand what they are before we start thinking of integration, crosswalk, or interoperation between them. Because if a European satellite, for example, malfunctions, how NASA can help would be visible through these interlinks. But at least in their own right, we should study these. And Robert, your comments would be very helpful in that area. That's why this question.
Mhm. One thing, if I can follow on a little bit, is one thing I think we do not focus on enough, maybe, is bringing out the fact that formalization of ontologies, once you have done the deep thinking and the conceptual modeling and looked at all the vocabularies and the use cases, formalization leads to automation. And it's the automation that is really the where you will get the value. If you can get coherent ontological modeling with automated monitoring, mitigation, that kind of thing,
Yes.
then yeah. So Rob, you might want to add that into your thinking about the value proposition, that people need to do the broad conceptual modeling, vocabulary collection, that kind of thing, in order to get to formalization, in order to get to automation. And then what does that offer? That your different possible clients, stakeholders, et cetera, and use cases.
Great point. Thank you.
You want to elaborate a little bit, Robert, or?
I think Janet made a great point. I agree.
Yeah, I think both points you made are very great, Janet. And we need to, of course, we have captured, but we need to also request you to, if you can kindly send a paragraph on the chat or later on to Ken so that we can capture this. And request you to, one more thing, I would request Mark Underwood to kindly stay on after our recording so we can discuss some of the future programs as well as anybody else who has ideas on future speakers for our summit or next year's summit. So
Robbie, you had a question or comment?
I have one or two. Let me go back to the chat board. One is, I made some comments on the cross domain. When you talk of something particular, let's say a set of when you have a set of subjects under urgency, let's say a disaster topic of space debris of some sort, at that time you need other domains information. What's the orbit? What's the decay rate? What are the kinds of fragments? Is there a real-time feed giving me update on these data? How likely am I to collide, etc.? These are follow-on questions that come from other domains. So that was one comment I wanted to make, Robert, that inherently many times we get sucked into multi-domain, cross-domain collaboration or integration need to do any kind of risk mitigation. That's one point I wanted to make. And second is Mark, let me openly then ask the question, would you like to speak, or Mike Ashold or anyone else? Because I thought at one time there was an interest in speaking in this summit. Mark, since you have to go, I have to ask this question
Sure.
urgently.
Yeah, my conflict is I am the chair of an IEEE meeting that is every other Wednesday, so I can't do next week. I'm interested, but aren't we kind of done with this go around?
Are you going to be able to speak at a couple of weeks later? Yeah, are you saying in
I could
2
do that.
So let's fix you to speak on 2 weeks, and we can do, week after the next week, and then you would kindly communicate to us the topic and title and so on.
Okay, sure.
Appreciate your.
You bet.
Sorry to get it as part of
worries.
recording, but there's no harm. Why? Why not? Thank you. Right, Ken?
Well, one aspect of these, space hazards is that they are very much situations, and you need situation awareness.
Yes.
And our hope is that next week we're going to have a speaker who will talk about situation awareness. But in general, the situation awareness community is having their annual conference in a couple of weeks. So I won't actually be available in 2 weeks because I will be at that conference. So this is the conference where I will be hosting a workshop that's going to be on June 10th, I believe.
Oh, so that is not a Wednesday.
But the conference is all week. And my workshop is on the Friday, the last day of the conference. And this workshop is on interoperability for situation management and decision making. And the idea is that first of all, you need interoperability in order to make decisions because you need to grab information from so many different sources.
Yes.
But another sort of meta issue is there are so many different techniques for decision making that could be utilized cross-domain. So something that was useful, say, in environmental or pandemic decision making could also be used in space disaster decision making.
Oh,
So if there was more of a standard interface and ontologies, especially for decision making techniques, then we'd be able to use these sophisticated techniques in other areas.
yes. So what you are referring to, very good comment, and obviously you are hosting something, so you have thought a lot about this. But the important thing is that even for a problem at hand, you need cross-domain inputs in real time. And you're talking of next higher level use, which is valuable use, namely knowledge reuse. What I learned in environment disasters, can I reuse in space situational awareness and so on? Yes, or for space debris and so on. Yes, that's a higher level of value proposition, more value. Or at least the least value is problem at hand. Can I use other domains knowledge to solve this problem at hand? So both are valuable. Thank you, Ken.
Yeah,
Robert, you want to say anything?
so yeah, Robert.
Um, no, but everything, all the points everybody made are great. Yeah, thank you.
Robert, before I forget and Ken forgets, I want to say that your presentation was excellent. You have given us a very good overview and specific examples, especially your work, and we are delighted to have had you as a speaker, and we reserve the right to send you follow-on questions. Thank you so much.
Thanks so much, Robbie. It's very kind.
Thanks, Robert. And with that, I think we should adjourn the meeting.